So we are starting on page 75 today in your student and we're starting 4.1, exploring scientific notation. Order the tiles from least to greatest numerical value. Explain how you know your order is correct. So they have all these tiles with all these different numerical values on them. And if we just take a quick look at them, we can see some of them equal other ones. So let's take 30 for example. 30 is the same as or equals this one right here. 3 times 10 to the first power. 3 times 10 to the first power, that's just 3 times 10, well that equals 30. So now let's look at other ones that match. We see 300 here, I'm going to put a 2 there, is equal to which one? It's equal to 3 times 10 to the second power. So 300 is equal to 3 times 10 to the second power, because 3 times 10 to the second power is equal to 100. 3 times 100 equals 300. So let's find our next one. If it went the first power, the second power, chances are we're going to find third power and add another 0. See at 30, 300. So if we added another 0, we're going to get 3,000. So 3,000 is the same as or equal to 3 times 10 to the third power, because 10 to the third power is 1,000. So 3 times 1,000 is going to give me 3,000. And our last one, we have 3 times 10 to the fourth power, and we also have 30,000. So 30,000, and notice we added another 0. This one has 4 zeros, this one has 3, equals 3 times 10 to the fourth, which equals 3 times 10,000, which gives me 30,000. And I forgot to add all these commas in. So now let's go down to the reflect question. Is there a pattern between the numbers and the expressions? If so, describe it. And there is a pattern. That pattern is for the value of the exponent, the value of the exponent matches the number of zeros. The number of zeros. So, and if you look back up there, you know, and if you look up there, you notice that 10 to the fourth power is equal to 1 with 4 zeros coming after it. So 1, 2, 3, 4. So 10 to the fourth power is equal to 10,000. If we had 10 to the fifth power, it'd be equal to 1, because that's our number, with 5 zeros coming after it. So that would give me 100,000. Okay, so again, they give you a huge space for very little problem. So please pause here, write key concept scientific notation and all this, and we're going to talk about it. Pause here. So now that you have written this down, you can see that scientific notation is just the product of two factors. One factor is between 1 and 10, and in that case is going to be this 6.92. So I'm going to underline both of these in red. And the other factor is an integral power of 10. So it's going to always be a power of 10, meaning this exponent here has to be an integer, and it's always going to be taking a power of 10. So we're going to have a number times 10 to the power of an integer. So we're not going to fraction or decimal up here. It'll be a positive or negative number. Now, how do we write this in standard notation? So this is scientific notation. Standard notation is going to be writing it out. So we have 6, 9, and 2 times 10 to the fifth power. All that means is that we're going to take this decimal and move it over 5 spaces. So 1, 2, 3, 4, 5. If we did it here, 1, 2, 3, 4, 5, and we're going to move it 5 spaces over. Now in these 3 blank spots, we're going to just add in zeros. So 6.92 times 10 to the 5th power actually gives us 692,000. So we're going to be doing that today. Let's flip our page. Alright, so we're on our got it, page 76. It says order the following numbers from least to greatest. So we have 2.34 times 10 to the second, and the second one is 2.34 times 10 to the negative 2. The third one is just 2.34. So you might be thinking, oh, this one has a negative exponent, and so it must be less than this one, and you'd be right. So I want you to know that negative exponents indicate small numbers, very small numbers. And positive exponents are large numbers, as we're used to. So just how we knew that negative exponents get flipped down to the bottom of a fraction, I'm going to do this in red over here. This actually equals 1 over 2.34 times 10 to the negative 2. So that's going to be our smallest one. Oh, not negative 2. Times 10 to the second. What's going to be our next one? Well, our next is just going to be 2.34. Because we know that this one here, 2.34 times 10 to the positive 2, is going to be large. Large number, small number. This is just your number. Alright, so now you try. Go to page 78 and do number 1. Order the numbers from least to greatest. You can just draw lines to whatever box they need to go to. Okay, so our least number is going to be this one here. It's underlined in red because it's 10 to the negative 5th. That's going to be our smallest one. Our next smallest will be 10 to the negative 3rd. Then we get 10 to the 0th, 0 power of 0, and 10 to the 3rd. Okay, now move on to got it, page 76 again. Which of the following numbers are not expressed in scientific notation? Well, we know we have to have a number first between 1 and 10. So 1 to 10. It has to be times the number 10, and then it has to have an integral exponent, an exponent that is an integer. So this matches all of those. So this one is written in scientific notation. It has a number between 1 and 10 times by 10, and then has an integer as an exponent. Next one, we have number between 1 and 10. No, we don't. This is 27.3. If it was 2.73, that'd be a little bit of a different story. So this one is not expressed in scientific notation. What about this one here? 8.04. Is that between 1 and 10? Yes, it is. So it is expressed in scientific notation. Also notice that your exponents can be negative. So now you try, go to page 78, do number 2, pause me here, try it out, see if you get it right. So notice that this one says circle the numbers that are expressed in scientific notation. This one said circle the numbers that are not. So if you got those switched, just switch them now. But notice the only reason why this one is not is because this number is not between 1 and 10. Neither is 0.04. So the only ones that are this one here and this one here. Alright, got it, page 77. Suppose your calculator display shows 7.7e to the negative 11th. Express this result in scientific notation. Well, this e right here just means times 10. So scientific notation would be 7.7 times 10 to the negative 11th. And this is written in scientific notation because we have an integer as our exponent. It's times 10, and we have a number between 1 and 10 as our first factor. So now go to 78 and do the you try. Same type of thing. Pause me here, see if you get it right. Alright, so you should have gotten 6.5 times 10 to the 21st power. This is positive this time. So remember again, this e right here just means times 10. So you can replace that e with times 10, and we move this number here up to our exponent. So please now go ahead and start your 4.1 digits homework. It's on your to-do list. It's numbers 1 through 15.